Hey Precalc, in this video we're going to be starting section 12.2 and introducing some limit properties. So the limit properties are, there's a lot of them, you do need to know them, but they aren't that bad. They are all kind of intuitive actually. So let's just get into it. So the sum property is the limit as x is approaching c of f of x plus g of x. We can rewrite this as the limit as x approaches c of f of x plus the limit as x approaches c of g of x. It kind of reminds me, these properties kind of remind me of logarithms. Okay, so we can separate them even further. Similarly for the difference property, the limit as x approaches c of f of x minus g of x can be broken up into the limit as x approaches c of f of x minus the limit as x approaches c of g of x. The limit as x approaches c of a constant times a function, so this is a scalar multiple property, can be rewritten as k times the limit as x approaches c of f of x. The product property, this did not print well, it should be a multiplication symbol. The limit as x approaches c of f of x times g of x, I bet you could guess what I'm about to write. It's the limit as x approaches c of f of x times the limit as x approaches c of g of x. For division, similar, but there's a little rule. So the limit as x approaches c of f of x divided by the limit as x approaches c of g of x, as long as the limit as x approaches c of g of x, because it's in the denominator, it cannot equal 0, right? Or else it would be undefined. If we have an exponent, we can think of it as the limit as x approaches c of f of x, whatever that is, all to the power of n. And then radical, kind of similar, we can take the radical of the limit as x approaches c of f of x. This one also has a little rule, so it just is if the limit as x approaches c of f of x is greater than 0 when n is even. Right? Because then we'll have some complex issues. Okay, so these are all the properties. We went through them kind of quick because, again, they're relatively intuitive. So now we're going to do some examples using the properties. So to algebraically evaluate a limit, what we can do is apply our properties to evaluate it without using tables. So I have limit as x approaches -1 of 2x squared minus 3 over x plus 2. So because I'm dividing, the first thing I'm going to do is use the quotient property. So I'll rewrite this as the limit as x approaches -1 of the numerator, which is 2x squared minus 3, divided by the limit as x approaches -1 of the denominator, which is x plus 2. Now, so I guess I could write, so this is the quotient property. Now we could use both the sum and difference, so difference in the numerator, so we'll do the limit as x approaches -1 of 2x squared minus the limit as x approaches -1 of 3. So in the numerator we're using difference. And then I'm going to use the sum in the denominator. So the limit as x approaches -1 of x plus the limit as x approaches -1 of 2. And we're getting close. Now over here, I'm going to do a combination, right? We have a product and we have an exponent. So I can rewrite this with the product on the outside of my limit statement. And then for the exponent, I could do the same. So I'm just going to break it apart. So in this second line, we used the difference property. And we also used the sum property. And then in this line, I bring the rest down. And here we use two properties as well. We did the product. Or actually, it wasn't product, it was the scalar multiple, because there's only one thing. Scalar multiple. And then we also use the power property. Okay, so now's the fun part. Now we can take the limit of everything because all we're left with are constant functions or identity functions, aka just a line. So here I'm going to do 2 times, and then the limit as x approaches -1 of x. This is using what's called the identity function, but basically because x is approaching a number and we only have one thing right here, x, this is just going to be -1, or whatever this value is. Here we have the limit of a constant, right? So the limit as x approaches -1 of a constant is just going to be that constant. So again, this is going to be -1, and this is going to be the constant. And then we can simplify everything. So 2 times -1 squared is 2 minus 3. And then -1 plus 2. So that means that our final answer is -1. And we're done. Oops, sorry, you can't see. Okay. All right, so there are 2 U-try problems if you printed this out. So I would recommend pausing your video now, and I'm going to stop recording and do this as well, and then I will go over it. All right, so hopefully you paused the video and did this, and we'll see how you did. So the first thing you should have done is break this all apart. You can combine it and do the sum and difference properties. Then we need to do the the power property and the scalar multiple property. And then we can take the limit. So the limit as x approaches 3 of x is just going to be 3, and then I brought down my exponent. The limit as x approaches 3 of x, again, is going to be 3, so I brought down my 2 in parentheses. And then because this is a constant, it'll be -7. 3 squared is 9, plus 2 times 3 minus 7 will give us 8 as the final answer. All right, let's have you practice one more. So try to pause the video again and do this on your own, and then I'll go over the whole thing. All right, so this one should have been pretty quick because we have a radical, which means our limits can be moved inside, right? That's the nth root property. So we have the limit as x approaches 2 of x, and then I also did the sum property at the same time. And then because everything's already separated, we can take the limit of both. So we get 2 and 4, and then we just add the 2 together to get 6. We cannot simplify this any further, so we are done. So those are some examples using the limit properties. I recommend doing a couple more practice problems on your own to make sure that you feel confident about them.